fiberboard production line. The continuous thin MDF HDF boards are produced with wood fiber as raw material through working sections of shipper preparation, fiber preparation, resin preparation and supply, forming and pre-pressing continuous rolling, and finished products preparation. The density of the board is 750 to 880 kg per cubic meter. The raw materials are wood and brushwood. Plant auxiliary workshops include transformer house, boiler shop, compressed air station, cooling water system, laboratory, dust moving system, and glue storage and conveyance system. Shipper preparation section. By manual, the raw materials are put on the in-fed bed conveyor, which is in front of the shipper. Automatically, raw materials are conveyed into the shipper by in-fed bed conveyor. Then, materials are cut into certain specifications wood ship by shipper. The shipped woods are conveyed into a screener by outfit conveyor. Additionally, the outsourced wood can be firstly conveyed into underground shipper silo. Then, the outsourced woods are put into a screener through outfit bed conveyor. Dusts, dirt, sand, and other impurities in the wood are removed by the screener. The qualified shippers after screening are transferred to a bucket lift. By bucket lift, the shippers are delivered onto an in-fed bed conveyor, which is before preheat silo. The shippers, removed iron by magnetic separator, are sent into preheat silo. Section K equipment. In-fed bed conveyor, shipper, outfed conveyor, screener, underground wood silo, in-fed bed conveyor, bucket lifter, bed conveyor, magnetic separator, preheat silo, fiber preparation drying section. The shippers are preheated and softened with steam in the preheating silo. The softened shippers are conveyed into a feeding screw of thermophile by a vibrating discharge device. Sent by a variable diameter screw to a vertical digester for digestion. The softened shippers are sent by feeding screw to the grinding chamber of the thermophile for fiber separation. The wet fibers after grinding are discharged by high pressure to the drying duct. The wet fibers are mixed with the hot air as the drying medium in the drying duct. The fibers are suspensions that in the drying medium by high pressure airflow. The moisture of fibers is taken away by the drying medium for purpose of drying. Cyclone separator is used to separate the fibers from air. The dried fibers are sent through the separating and discharge valve to the winnowing machine. And through the winnowing machine, the dried fibers are sifted and eliminated resin cakes, fiber cakes, and coarse fiber stalks. Next, the fibers are delivered to the forming machine by pneumatic pressure. Section K equipment: preheating silo, feeding screw, steam cylinder, feed screw, thermofinder, discharge valve, dryer, winnowing machine, unloading valve, resin preparation and supply section. The technology of resin application prior to drying is adopted by us. Water repellent paraffin is through heating and melting. The melting paraffin is directly put into the thermofinder according to a certain material ratio. Paraffin is sufficiently mixed with the fiber and gradient squeezing by the two gradient discs. Resin input through storage tank into mixed tank, and fixed cool agent after measuring are mixed. The mixed resin and cool agent are sent through separator pipes by pressure to the fixed nose of the thermofinder for sufficient mixing. When the resin and fiber meet each other in the drying duct, the resin fog attaches to the fiber surface at a high-speed airflow of 28 to 35 meters per second. The system consists of flow sensor, computer control console, and speed regulation resin applications pump. The speed of rotation of the resin applying pump can be continuously adjusted automatically to trace the theoretical resin quality for a constant ratio of fiber to resin quantity. Section K equipment: paraffin melting tank, resin storage tank, resin mixed tank, and paraffin apply system, bleeding system, flow sensor, regulating and bleeding pump system. Forming preparation and metal transfer section. The screened fibers are put onto a measuring silo or former by fiber winnower. High-quality forming machine is indispensable for high-quality thin boards. Mechanical forming machine can meet such requirements. On top of the dosing bin, there is a switching device for material spreading to ensure the same height of the fiber accumulation in the width-wise direction. A raking device is installed on the dosing beam in the lengthwise direction to ensure that the height of fiber pile between the dosing beam and the material throwing ruler. A larger diameter is single-head forming ruler, rotates at high speed and throws fiber forward along the tangential direction of the forming ruler, forming a smooth and uniform mat structure. The formal mats first need to be through magnetic spreader for iron sandwiches, removing so as to prevent the metal substance from getting into hot press. To monitor moisture content of shaped metal, this line is equipped with a high sensitivity moisture meter so as to back-feed the results timely and adjust process. Formed and shaped mats are sent into pre-press. The pre-press we choose has a long feeding section with a small angle of inclination, so the air in the mat can release slowly. Otherwise, the fibers on the surface of the metal may be blown up, resulting in surface damage. The fiber mat is compacted and its relapse is restricted by the pressing rulers and 6 pairs of pressure-keeping rulers, resulting in high density and high strength of the mat. The mats after pre-pressing are cut off the unnecessary edge by trimming machine and recycle the cut parts. Pre-pressed mats are sent onto the bed conveyor. Transfer of thin fiberboard is very important. We use a single long belt for the transfer in this section. This single belt conveyor starts from the exciter of the pre-press and ends at the entrance of the ruler press. If defective mat is found, a carriage and expansion bed can be used to send the waste mat to the waste mat recovery system. The waste mats firstly are broken by shintering machine and then recycled by waste mat recycling system. The qualified mats are directly sent into continuous type hot press. Section K equipment. Former dosing beam, former ruler, magnetic separator, moisture meter, continuous type pre-press, trimming machine, telescopic type belt conveyor, metal shintering machine, waste metal recycling system, trimming and recycling system, continuous ruler pressing section. This is the core section of the production line. The equipment combines fiber forming, mat pre-pressing and hot pressing together. A ruler press consists of a large diameter hot pressing ruler, 2 press rulers, 3 guiding rulers, pressing steel tapers, frame, cleaning rulers, and etc. The The steel table is made of high-strength stainless steel with a high degree of finish. In order to ensure that the press steel table keeps working between the large pre-press ruler and the guiding rulers, a transmission deviation monitoring device is used to monitor the edge of the steel table. In case a deviation is detected, the guiding ruler at the tail of the ruler press will make an adjustment automatically to the vertical inclination angle. Metal is in the process of hollow pressing to shape through hollow press ruler and compressed ruler. The pressed boards are converted into a storage track for cooling through the guiding ruler of ruler press. The section is equipped with a clearing ruler so as to clear the dust and sundries of steel belt. The cleared dust is recycled by a recycling system. The section is equipped with an advanced hydraulic pressure system, lubrication system, secondary recycling system, and electric control system. Section K equipment. Continuous type ruler press, heating ruler, pressed ruler, guiding ruler, heating steel bed, rack, steel clearing device, dust recycling system, hydraulic system, lubrication system, secondary recycling system, electric control system. Finished product preparation section. The cooled-down rough board is transferred by a drawing bed conveyor to the longitudinal saw and causes sewing, cutting saw by sawing treatment for finished board. The finished board after sawing is stacked on a hydraulic platform lift. When the boards are accumulated to a certain height, a forklift is used to transfer them to the finished product warehouse for storage. The finished boards after cutting are put into the finished product warehouse, and products can be directly marketed or in the process of sending according to the buyer's requirements. Electrical control system. The PLC controller is used as the electrical control system for centralized management. The operator machine interface display screen can provide display and dynamic information about the technological state of control accuracy. Combined automatically and manual operation is also made available. Section K equipment. PLC control system, operator machine interface, control cabinet, operating floor, control room. Auxiliary workshop, glue supply shop, equipped with the conveying glue system, glue storage tank, and etc. Compressed air station, equipped with air compressor, air dryer, air filter, air storage tank, and delivery system. Boiler room, equipped with steam boiler, conduction oil boiler, fuel feeding system, water treatment system, dust removing system, steam and oil recycling system. Cooling water system, equipped with the cooling tower, water tank, and water recycling system. Laboratory equipped with the universal test press detect all kinds of strength. Moisture meter, free formaldehyde meter, dryer, meter quality test device, and glue tester device.